Okay, we've been talking about processing files, and I want to just take a quick look at something else about data files. We have this data file here that was in our example PowerPoint where we have several records or rows, and each of these can have a new line, a \n, basically at the end of it to know that it's the end of the row. Within our row we have different fields that could be formatted many different ways. It depends on our program and how things were written. Now, when we're looking at a sequential data file, we're going to open that file, and when we can begin processing it, we're going to be reading from the beginning, record 1, then record 2, all the way across all of the rows of the table until we get to the end of the file. We're going to use the StreamReader and StreamWriter classes to do that. Here's an example of instantiating an instance of a StreamWriter named output file. And here's the actual file name that we're wanting to write. And then here's an example of instantiating an input file, a stream reader. Again, our file name is the parameter. Now, as our program reads through the records in our file, we're going to be using the instances of our StreamWriter or StreamReader to do that. So, for example, if we want to write something to our output file, we would specify our output file instance name, and then after a dot, the method that is available, because that is an instance of a StreamWriter object. The write line method is available, so we would specify that method name, and then as our parameter, the string that we would like to write. If we're using the StreamReader, we would start out with our variable name of a string to read, and then after our equal sign, we would specify our instance name, followed by a period, and then the method name of the method that is available from that StreamReader class that we would like to use to read something from our file. Now, there are many other methods available. These are just examples. So the dark brown objects are variables that we've created. The grayish color are our object instances of our StreamWriter and StreamReader. And lastly, the orange color is a method name that's available from that StreamWriter or StreamReader class. Now, sometimes we need to directly access a specific location in a file, so we can use a seek command, and we can use that with the binary reader and the binary writer class. Let's see if my beautiful animation is in the wrong order. There we're seeking, so we can just move to a specific location in the file, a specific offset from the beginning of the file. Now, to instantiate a writer and a reader in a binary mode, again, we would just specify the binary writer or binary reader class name, followed by our instance name, followed by the fact that we would like to instantiate a new instance with a given file. Now again, when we're working with our binary writer and reader, our syntax is similar. We would use the instance name. There goes my animation, nice. We would use the instance name, followed by a period and the method name, and then the variable that contains the data to write to the output file. When reading data from a binary or a direct access file, we would specify the variable that we want to populate, preceding the equal sign, and then after the equal sign, we will have the instance name of our binary reader, followed by a dot and the method name that we want to execute within that binary reader class. So depending on which direction we're going, it's whether we're going to specify our variable as a parameter or as an updated component. So let's do an example, and I'm going to bring up the project that we've been working on so far in Chapter 13, and I'm going to create a new project within this solution. And I want this to be a Windows Forms app, and I'm going to name it This is going to be one of the examples that's in our book. Let me get back to it. This one is going to be example 13-3. For our new example, I'm going to make it be our startup project. And then I'm going to update our form name to match the textbook. Our solution name won't match, but we'll make our form name match. So let's rename that. And we want it to be FRM saying GUI for GUI. Now I'll leave our program.cs file named as it is, but I am going to close out some of these tabs that I have open from our previous projects so that I don't get things confused. Now for this sayings app, what we're going to do is in the first iteration of it, we're going to write an output file with a list of sayings. So let's fix up this form. I'm going to make the back color blue like they want it in our book. And I'll make my forecolor. Let's see, I can go with a gray. Let's see how that looks. And I want my font to be 12. And again, I think I'll go with a Arial type font. And I'll minimize, make this a little bit smaller. Now I want my form title to be meaningful. So I'm going to make my text property say sayings app. All right, there we go. Now in our sayings app, we're going to be reading a file. But I think I need a few more things on my form. Let me find the example. I will show it to you. Here is the example. We want our application to have a text box where our user can type in a saying, like the early bird catches the worm type thing. And then we're going to have a button that allows them to store that saying. So I really want my title to be Favorite Sayings Storing App. That's a long one, huh? Favorite Sayings Storing App. Whoa, really long. Now, I need a heading. I'll just grab a label here, put it up at the top, and it's going to say something like enter favorite saying. And I can't see that color at all, so let's go back to my form and change that for color to something a little bit easier to see. Just do black. And then on my label, I think I'm going to make that font bigger because it's a bit of a heading. And I'll go right now, 145, how about 14? And I'll make it bold. Right, under our prompt there, we're going to have a text box. Now my text box I want to be multi-line. And I want to name my text box TXTBX saying. And then underneath that I want a button. And my button is going to be named BTN Store. And I want it to say in its text property, yep, that's all right, store saying. And you can use that multi-line drop down if you need to, anytime. Now my back color is messed up, of course. All right, I don't really need all this extra form. I think that's all we need on our form. Let's go ahead and put a label down across the bottom to hold a status message. Put it down here, and I know Visual Studio will resize it. I'll make that label's text property say something nice like welcome to the sayings app. All right, not too bad. Let's run it, make sure everything works. Oh, looks good. It comes up, everything's okay. So now I'd like to add some code, and I'm going to have some code associated with a couple of different events for this application. Now the first one will be our form load. So whenever our application starts, we're going to try to read our sayings text file and see if we have such a file. So let's double click on a blank spot on our form to create that form load event procedure. And now in our form load, let me move some things out of the way. We're going to have some code. Before we do that, let's update our using statements. We need using system.io. We also need windows.forms because we are creating a forms application. Now in our class, we're going to create a class level variable to hold our file information. This class field is going to be private to our class, and we're going to make it a StreamWriter type for this example, and it's going to be named file. Now we're just declaring that object. See if I can type. Now we'll be able to access that in any of the methods within our class because it is a class level variable. So we'll be able to instantiate it as an instance whenever we want to. Now in our form load, let's go to our form load event. We will want to do that. So in our form load, we're going to enclose this stuff within a try-catch because when we're working with data files, anytime we're doing I/O, input, output, we are making our program dependent upon this external resource, this file. So anything could happen to that file. So we always want to enclose all of our logic within try-catch. So we're going to create an instance of that file object. We're going to say this is a new StreamWriter, and I want it to open a file named saying.txt. Now if we don't have a path name on that file, like this, remember that's a relative path, so the system is going to expect to find that file within the bin debug folder of our project. Now let's put in some additional information to go along with our try. We're going to do a separate catch on a directory.found exception. If we get an exception like that, we want to catch that exception and name that exception object exe. Within our catch then, we will update our label message. Oops, did I not name it? Let's go name it. I put a message in there, but I didn't name it. LBL message. There we go, that should be better. So now I should be able to see it in my drop-down. LBMS lmessage.text. And notice I'm not using the this keyword. It's totally optional if you want to use that this keyword. IntelliSense seems to be able to drop down either way. Now I'm going to set the text of our message equal to invalid directory plus I want to add to that the exception message. Notice that when I typed the period character, I had a drop-down list of available options, because exe is an instance of our exception class. Now, if I don't have a directory not found error, I could also have a system.io exception. And there is a fill in the blanks question about that, and do use caps there for all those different characters to get that to match up properly. Now, if we do catch an IO exception, we'd also like to catch that exception object in an instance variable named exe. Let's use that and to update our message on our form. All right, so now we have our form load. We're trying to open this saying.txt file. If we have an error, we're going to catch that error and update our message. So let's see how that works. I'm going to run it. Didn't get mad at me, shouldn't it get mad at me? Let's make sure it ran that. I'm going to put a breakpoint here. Run it again. It is working. Now, our saying.txt file didn't exist. Why are we not getting an error? Let's check. I'm going to get rid of this breakpoint because it just showed me that my code is indeed executing and I'm not getting an error. So why is that? Let's look over here at our Solution Explorer and remember how we changed to folder view. Let's change to folder view. I'm looking at exercise 13-3 here. And now if I look at my bin debug folder, oh look, my saying.txt file does exist. So this statement here saying that I wanted to write this file, saying.txt, created that file for me. Awesome. Let's go back to our previous view. Now, lots of stuff here. Let me close it. That's what I want. Solution folders. Do a little clicking around there. Try some things. Okay, so my form load is working. It's creating the file for me. And now I'm ready to add some stuff to save some information. Let's put some comments up here though. For our form load executes before the form displays. Open our saying.txt file for output. Now, in our program, the other event that we want to be concerned about is if someone clicks our button. So let's go to our form and double click on our button to create that event procedure. If somebody clicks on our button, we want to take the information that's in that text box and we want to write it to our output file. To do that, we want to enclose our logic within a try-catch. Now remember, our FIL object is a class level field, so we're able to access that object from within this event procedure. I want to use the write line method that's available through that StreamWriter class. And what I want to write is my text box saying.txt. Now after I've done that, I'm going to clear out my text property of my text box, and I'm going to put the focus back on the text box, and the focus means that my cursor will be back there ready to type something new in. Now I want to put my catch logic in. If I catch a system.io exception, I want to save it as an exception object named exe, and I want to output its information to our LBL message.text property. Now, we shouldn't need to catch anything else there. Let's try things and see where we are. We'll put a comment up here. This event will save data to the text file. So let's run our program. I'm going to put in a saying. And click Store Saying. Now I'm going to close out. And I want to look at that text file. Now I want to look at it in File Explorer. So I'm going to use my solution to right-click and say Open Folder in File Explorer. I'm going to go into this exercise, bin, debug, and I'm going to look at my saying.txt file. There's nothing there. But I will tell you why. It's because we didn't properly close our file. So when we allocated our StreamWriter instance, it opened the file, but we haven't closed it. So let's add something in to close our file. We want our file to close automatically when our form is closing. So let's click on our form and looking at our properties, let's go to our events. Now in our events, I'm going to scroll through all these events until I find one that says form closing. And I want to type in the name of this event that I'm going to create. FRM saying GUI underscore form closing. Now when I press enter, Visual Studio will create that event method header for me. There we go. Now this is going to execute when they try to close our form. Again, we're going to close our file, so we want to enclose that within a try-catch. And we're going to say close our file. Now we'll try to catch an error here. Actually, we'll just leave it open and say any error that's caught, output to our label, file did not close properly. All right, so let's put a comment here. This event will fire when the form is closed. It will close our file. So let's run it now. The early bird gets the worm. Store saying. Now I'm going to close. And I still have this File Explorer window open with our bin debug folder. So I'm going to look at our saying.txt file now. And sure enough, it has my saying in it. So what if I leave this file open here in Notepad and try to run my program? Do you care? Did it care at all? We still have it open. Did we make it mess up? No, we did not. We got our new message. So we can tell that Notepad is just sitting there looking at a copy of that file. It's not keeping it open. It's not keeping it locked, which is great. But another thing for us to open is that, or notice, is that every time we run our program, we're updating this file and eliminating the contents of the file that were there. So is there a way that we could make that add to the file instead? Let's try. I'm going to type a comma here to see the other parameters to the StreamWriter. And it says that I could do encoding there. Well, that's cool if I wanted to do that, but I don't. So I'm going to keep looking. Oh, bool append. Initializes a true new instance of the StreamWriter, blah, 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 blah. If the file does not exist, the constructor creates a new file. Append, true to append data to the file, false to overwrite the file. So let's put true there. Now, right now it has that weird message in it. So let's put a different saying out here. How's that? Now, again, I'm going to look at File Explorer, look at my saying.txt file. I'm just seeing the other. Do I have to close it? Oh, I do, don't I? I have to close it to commit that change. Now, I should see both of my messages because I appended. So appending means adding more. So that's what we want to do with that append flag. Now, before we close this application, a couple other things that I'd like to do. If you notice, when we run it, we say, welcome to the Sayings app, no matter what. Let's update our message a little bit. Whenever we use the store button, let's update that message to say something like, saying stored. Let's run it. Here comes the sign, right? Store it, and now we get a nice message says that our saying is stored. I'm going to close the file, open it in File Explorer. Wrong one, too many open. (13.3) bin debug saying.txt, and there's my new saying in the file. Okay, so that shows us how to write a standard text file, try some different things, gives you a lot of different capabilities. So we'll be back with another video trying to read our file.